Hi everyone, welcome to my channel, Tutorlini Test Prep. Today I'll be providing a full walkthrough of the Digital SAT Math Practice Test number 11. I highly recommend you complete the exam yourself in the Blue Book app before watching this video. Let's get started with Module 1. Okay, this is the beginning of Module 1, Question 1. We have this equation 4x plus 1 equals 33. Whenever we do algebra, we kind of think in terms of reverse PEMDAS. Regardless, the coefficient 4 is one of the last things we move. So we're going to move this 1. The 1 is being added. The opposite of addition is subtraction. So we will subtract 1 from both sides. 1 minus 1 is 0. And this will leave us with 4x equals 33 minus 1, which is 32. And we don't even need to keep going. We can see that that is choice A. We can also do this one entirely on Desmos, so let's go do that. Okay, when you have a simple equation without anything wacky in it, you can often just type it in left to right as is. So I typed in the original equation, and now I'm going to look at each of the answer choices, and we see the original equation gives a solution of 8. So let's look at all the other ones. It seems the only one that gave a solution of 8 is the blue one, which is 4x equals 32, which is what we got. Choice A is the answer. Okay, question 2. So they're telling us that x equals 2, so we're going to replace all the x's with 2's. In other words, we're going to find k of 2. Always use parentheses when you substitute. Okay, so I've got 2 cubed. That is 8 plus 110. 8 plus 110 is 118. So the answer to this one is choice A. We could also do this entirely on Desmos, so let's go do that. Okay, so all I did was type in this function. Now I'm going to literally just type in x equals 2, and I'm going to see where they meet. And I'm going to zoom out so that I can see that a little bit better. And if I just click near it, it should tell me that that happens at a y value of 118, which is what we got. But an even easier way to do this that they didn't include in the question for some reason is to just use function notation. So if you just type in k of 2, you get 118. Okay, question 3. I go over this in great detail in my Ottocento number 9 and my short, which is on it's called mean of a list. So mean is equal to sum over n. So the sum of these numbers is, let me see, we're going to do 5 plus 2 plus 15 plus 9 plus 9. I'm getting 40. And there are 5 total numbers, 1, 2, 3, 4, 5. So we're going to divide by 5. That's the n, the sample size. And we get 40 divided by 5, which is 8. And that is the answer there. We can also do this on Desmos, so let's go do that. So this doesn't work well for frequency charts at all, but for lists, like in this problem, it's really handy. There's 2 commands. I put both of them, even though median isn't in this question. Don't let that confuse you. So the mean, and then you type in all the numbers, and you could also do the median. You could type in all the numbers. There's ways to store the lists. I go over it a little bit in my Desmos videos. Again, anyway, you see, if you look at that first line, we get a mean of 8. Okay, question 4. So the trick with this one is you just got to pay very close attention to what the variables are. So we've got x, and the question says that is the number of 2009 premium grade log cabin pennies. And then we've got y, and the question says that is the number of 1996 select grade Lincoln pennies. And the 170 is already in the equation. We don't need to worry about that. And it says there are 6 1996 Lincoln pennies. So remember, Lincoln pennies was the y. So let me highlight that in blue. So this is essentially telling us y equals 6. And now it says how many, I'll put that in a different color, how many, because that's asking a question. 2009 premium log cabin pennies are there. Okay, so that is the x, right? And we don't know what that is, so we'll put a question mark. So all we're going to do is substitute 6 into that equation. So we get 8x for y plus 11 times 6 equals 170. 11 times 6 is 66. We'll subtract 66 from both sides. 170 minus 66 is 104. We get 8x equals 104. And now we divide both sides by 8. And we should get x equals 13. And that is the answer, 13 of the log cabin pennies. I think we're 4 for 4 so far. We could do this one entirely on Desmos as well. Let's go do that. Okay, so remember what we said at the beginning. We said that y was 6, so let's just type that in. And we'll readjust to see where the point is. And I like to export it so that I can look at it. So when x is 13, y is 6. So you just got to remember what x and y are. So x was the log cabin pennies. They were asking us for x. So the answer is 13. What's probably going to confuse you guys on this one, really if you're doing it by graphing, really the only way to make a mistake is you mixed up x and y. And you can't highlight on the math section, at least at the time of this video. So what you should do is you should write down what the variables are on your scratch paper to help you prevent you from making a mistake. Okay, question 5. I go over this in great detail in my Ottocento number 24 on basic exponentials. Please go watch that if you haven't already. So right away I see this graph is not a line, it's a curve. So I'm already kind of thinking that these two are wrong, increasing linear and decreasing linear. Those are both wrong for sure. Again, decreasing linear looks like that. Increasing linear looks like that. Generally speaking, when you have positive constants and coefficients, I go over this in the video, increasing exponential will look like this, and decreasing exponential or decay will look like this. So I can very clearly tell this one is increasing exponential, so that is B. But really, if you're stuck, just kind of drag your finger with it from left to right. And if you're going up, it's increasing. And if you're going down, it's decreasing. So watch, I'm dragging my finger from left to right along the curve. It's going up as I go left to right. So that means it's increasing, getting bigger. So if you have any doubt, just do that. Okay, question 6. So we got a bunch of terms, 3 of them, and they're being added. What we want to do is we want to combine the like terms. So I'm noticing that there's 2 x terms. So we're going to try to combine those. So we're going to do 6x plus 5x, which is 11x plus 4y. And now you see we got an x term and a y term. Those are not like terms. They don't have exactly the same thing after the number. So we can't put them together. So we're kind of done. It has to be choice C. There's ways to do equivalent. You could plug in a number for x, like 2. You could plug in a number for y, like 3, and then guess and check all of them. But there's ways to do it on Desmos, but it really just doesn't help for this question at all. You saw how short this one was, right? So I would just do this one by hand. 6x plus 5x, 11x. Okay, question 7. So these triangles are congruent. So that means they are exactly the same. So that's why I drew two triangles that are exactly the same. They got the same shape and the same size, same corresponding angles, same side length, same everything. They're identical. They're like identical twins, right? So we're going to do A, B, C. When you label them, you should label them in the same order. What I like to do is I like to start at the top and then work my way around to the right. So A, B, C, and then go D, E, F. If you don't go in the same direction and in the same order, it's going to be wrong. So make sure you have the order match what's in the congruency statement right there. Okay, so we got A, B, C, D, E, F. Now we can start labeling the picture. So we got angle A is 27 degrees. And it says, oh, it also says, I missed this. It says E, B and E are right angles. Oh, I should have did a better job drawing this. That's okay. We could put 90 degrees. That's a right angle, right? And it says, what is the measure of angle F? Okay, so remember what I said? All the corresponding angles are equal. So this one's equal to this one. This one's equal to this one. And this one's equal to this one. And again, I'm getting that from both where it talks about it in the question, but also from the order in this congruency statement. I personally like to just look at this because I think that's easier. I don't like looking at all the words. I just look at the part at the beginning. Okay, so we know angle D is equal to 27. And we also know there's 180 degrees in a triangle. So we can do 180 minus 27 minus 90. And we get 63. So this guy is 63 degrees. And because they're equal, this guy is also 63 degrees. So the answer to the question, it wants the measure of angle F. So we're going to say 63. Okay, question 8. I go over this in great detail in my Ottocento number 24 on basic exponentials. If you haven't watched already, please go watch it. I put up the equation for a basic exponential, y equals a times b to the x, on the board. You see that's very similar to what's in the choices, right? Okay, so I kind of don't like this question. So first of all, what really stands out to me is it says r is less than or equal to 4. I think really you can't have negative rounds, right? And you can't have like a 0th round. Doesn't really make much sense in this problem either. We'll talk about that later. I think it should really say 1 is less than or equal to r is less than or equal to 4. Yeah, that seems like just poor writing. I don't really know how to get around that. Anyway, so really important here is I think what's at the end, right? So it says which equation gives the number of players P eliminated at the end of round R. So it doesn't mean cumulatively how many people have been eliminated. It wants to know how many are eliminated at the end of that particular round. Well, it explains at the beginning that half of the people are getting eliminated at the end of each round, right? So the multiplier is for sure 1/2. So I think we can confidently go ahead and cross off the ones that say 2. So B and D are out. So now we're between A and C. We got a 50-50 guess. If we weren't sure, that's pretty good. So now it's kind of like, like the y-intercept doesn't really make sense in this context because, by the way, guys, B is the multiplier, A is the y-intercept. Go over that in the video that I talked about before. So the y-intercept, here this is saying the y-intercept is 0, 15. And here this is saying the y-intercept is 0, 240. That's what you'd get if you'd graph it. And neither of those really makes sense. At the 0th round, you're not eliminating 240 people. So sometimes when you have a model, the y-intercept just doesn't mean anything. So maybe the best way to decide is to make a little table. So that's what I'm going to do. So we know it's between 1 and 4. Again, 0 doesn't really make sense, right? You could even just do the first couple. So we know that there's 240 people at the end of the first round. Half of those people are going to get eliminated. So that's 120. So now there's 120 people left. Half of those people are going to get eliminated. So that would be 60. And then half of those people who are still in, the other half who are still in, half of those will get eliminated. We got 30. And then 15. So if we plug in 1, we should get 120. Right? Because the 120 people are getting knocked out in the first round. If I plug in 1 into choice A, I get 15 times 1/2 to the 1. In other words, just 15 times 1/2. I'm getting 7.5. That can't be. We're not going to knock out 7.5 people. So A is definitely wrong. Let's see why C is right. So if we do 240 times 1/2 to the 1, that is 120. And you could check the other points too if you just want to be sure. 240 times 1/2 to the 2, that gives me 60. So if you kind of just think it through logically, make a table, you can guess and check the answer, even if you had no idea what was going on with what an exponential function is. You don't need to do this, but I might just make a nice picture just to put a bow on this. Give me 1 second. Okay, so I just plotted our table, and I put the points in a table, and then I plotted our answer, and then I just put in the domain restriction 1 is less than or equal to r is less than or equal to 4. And you see, that's another way to check. Oh, it looks pretty perfect. I don't know if you had time to do that too. I would honestly just plug in 1, 120, get it down to A and C, and then plug in 1, 120 and get the answer. Okay, question 9. I go over this in great detail in my Ottocento number 28 on literal equations. If you want to get these questions consistently right, please go watch it. All right, so I notice here it says in terms of, the thing that comes before that is what we want to get by itself. So we want to get r by itself. So let me rewrite this equation. And let me highlight the r. Most of the time, we could just kind of ignore whatever's on the side opposite from the isolated variable. We want to move stuff away from the blue. We don't want to move stuff towards the blue. We want to move stuff away from the blue. So really the only thing near the blue is this 38, right? So the 38 is being divided. So the opposite of division is multiplication. So we're going to multiply both sides by 38. And we get 38 divided by 38 kind of cancels out, becomes 1. We get 1r, or just r, is equal to 38 times s plus t. We could distribute that, but that it's important to, like, every time you do a step, glance at the choices to kind of see if you're on the right track to the answer. And kind of looks like C. We literally just have that. So we don't need to go any further. We're done. Okay, question 10. I have a short called parallel plus perpendicular slopes, and the short after that called equation of a line. Both go over this. Definitely go check those out. Okay, so the equation of a line is y equals mx plus b in slope-intercept form. And the slope of this line, line k, as you can see, it's the coefficient of x, which is 6. They tell us line j is parallel, so we're going to look at line j. Parallel lines always have the same slope, so instead of if the slope of that line is 6, the parallel slope is going to be 6. Whenever we have an x of 0, that is telling us the y-intercept, which is the b. So I don't even need to do any work. The b is 5. So the equation of line j must be 6x plus 5, which is choice A. We can also do this one by graphing on Desmos, so let's go do that. Okay, so this is a little crummy on my vertical version of Desmos here. It'll look nicer on yours, right? It's just for the recording. So I just typed in everything, type in the original line, line K, and we're just gonna kind of try to eyeball it. So, okay, so kind of hard to tell, but those are not parallel. They meet at 1,10. Parallel lines never touch, so that one's wrong. Choice D is wrong. Let's try choice C. Those definitely cross. That's wrong. Okay, choice B. Those definitely cross. That's wrong. Okay, choice A. If I zoom in on choice A, looks good. They're like going in the same direction. They never touch. This one always works. Sometimes I feel like it'll be hard to tell, but for this one, it works pretty well. Okay, question 11. I go over this in great detail, guys, in my Ottocento number 10, area and volume scale factors. This is one of the most poorly misunderstood concepts. Please go watch it. I also have a short that kind of goes over it briefly if you want the abridged version, but go watch the longer video and do the worksheet because the practice will help you. Okay, so the thing that they expect you to know here is that squares are always similar. I go over that in the video. That's just something they expect you to know. They always have the same shape, right? So we can use scale factors. So it says square m is 6 times the length of square n. Okay, so it kind of sounds like square m is the bigger one. So I'm just going to make a little sketch here. It doesn't matter. So square m will make him the big one, and then square n will make him the small one because square m is 6 times as big. Okay, so now I'm looking for either a pair of corresponding measurements or the word times. And you see, I kind of already mentioned, we see this word times here. So 6 times the length. That is telling us the linear scale factor, which we call capital K, and it is 6. The area scale factor for this problem would be equal to K squared. 6 squared is 36. So if the area of square n is 49, now we just have to think, do we do 49 times 36, or do we do 49 divided by 36? Well, 49 divided by 36 would give us 1.4 or something, and that's obviously not going to work. That's like way too small, right? You see, m is supposed to be bigger, right? Remember, we talked about that with the first sentence? So we're going to instead do 49 times 36. And that gives us an area of 1764. first square m, which is choice A. Okay, question 12. There's a couple ways to do this. I'm going to go over first what they want you to do, and then we'll go over a much easier way on Desmos, okay? So what they want you to do is to recognize that all these have x plus 15 squared in them. And the first algebraic step is to take the square root of both sides. So you could just do that, write that for all of them. So when you take the square root of a positive number in your algebra, you have to put a plus or minus sign, and that will generate two solutions. So you see 135 is positive, 45 is positive. When you go to take the square root of a negative number, like in this one, negative 45, you can't do that. Go try to type square root of negative 45 on your calculator. It won't work. So that means there's no solution, zero solution. And when you go to take the square root of 0, that's just 0. Even if you put a plus or minus sign, negative 1 times 0 is still just 0. So whenever you go to take the square root of 0 as that final step, that will generate just one solution because it's valid, but there's no plus or minus. You can't do plus or minus 0. It doesn't make any sense. Okay, so the answer is A. That was very hard to see. There's certainly other ways to do it by hand, but I think this is just so much easier to do on Desmos. So let's go look at that. Okay, guys, I go over this in the Desmos videos. Whenever you want to find how many solutions an equation has, you break it up into y equals left-hand side, y equals right-hand side. So I'm going to just go, so that we do the correct answer last. So let's do choice D first. I can very clearly see that it intersects twice. The blue and the red touch twice. So that has two solutions. Okay, so D is wrong. It's got to have one solution, right? Okay, the left side is the same for all of them. So let's just change it to y, the second part to y equals 45. That also touches twice, there and there. So that has two solutions. No good. All right. Negative 45. Oh, the blue line's way down here, so it doesn't touch at all. So that has zero solution. Okay, that one's wrong. We want it to have one solution, right? Let's see what happens when we make it 0. Okay, when we make it 0, it touches once right there. So that has one distinct real solution. So A is the answer. I definitely would have did it that way, especially since the left-hand side is all the same. It actually doesn't take that long to type in. Okay, question 13. So all of these choices have 1,150 in it. So why don't we just kind of ignore that and just look at the left side and treat the left side as like an equation of a line problem. I feel like that would go pretty good. So it seems like the x in this problem is the t. That's pretty clear. And then the thing they're measuring is the cost. So why don't we call that c? You just call them x and y if you want, but it's better if you call them something so that you remember what it is. So it says the cost is $950 for the first 3 hours. Okay, so when t is 3, the cost is $950. And then it says an additional $50 per hour for each hour after. Okay, so that's essentially the slope. But to make it easier to type in a Desmos, why don't we just come up with a second point? So why don't we, the slope is the change in y when x goes up by 1. So why don't we do t, make it 4, and then it goes up by 50. 950 plus 50 is 1,000. All right, let's come over here. Let's see what the equation of that line is. So I got 3, 950, 4, 1,000. Click on the regression button. I'm getting, so this would be like C equals 50t plus 800. You see it says that next to equation. I just changed the letters, that's all. Great, let's come back over here. Okay, so we're looking for a left-hand side that is equivalent to that. Or you could start plugging in the points on the left side and see if you get the same thing. But let's just look for one that gives us that. Okay, so 50 times 3t, that's 150t. There's no way that's right. We said it should be 50t, right? I think the same here. I don't even know what 950 times 3 is. And then plus 50? That's like 2900 t. There's no way that's right. Okay, 950 times t. There's no way that's right. Plus 50, it's even bigger, right? So we said it should be 50t. So this is 950 plus 50 times t minus 3. That looks really good. We can go through it just to confirm if you want. So if we distribute, we get 950 plus 50t. 50 times negative 3 is minus 150. Now combine the like terms. 950 minus 150 is 800. So this is 50t plus 800. That is probably the easiest way to do it. If you didn't want to do the regression, you could just plug in the 2 points into the left side, but that would maybe take a while. I think if you found the equation of this line, however you wanted, Desmos makes it pretty easy. You get 50t plus 800 and then just see which one looks like that. Okay, question 14. I go over this in my shorts slope formula, and I think the other one's called equation of a line. Regardless, so we got the slope formula y2 minus y1 over x2 minus x1. I'm just going to use the first 2 points because I think that's easier. So I'm going to make this my second point and this my first point. So I'm going to do 28 minus 32 over 2 minus 1. We get negative 4 over 1, which is just negative 4. Now we can write the partial equation, negative 4x plus b. If we plug in one of the points, let's say 132, I get 32 equals negative 4 times 1 plus b. Negative 4 times 1 is negative 4. I add it over to the other side, and I get 36 equals b. So the equation of the line is negative 4x plus 36. The question says, what is the value of b? So we're going to go with choice D. This is way easier to do on Desmos. Anytime you have a line and they give you at least 2 points, you're just going straight to Desmos. So let's go do that. Okay, guys. So I clicked the table. You click plus and then click table. Just did that with the magic of television. And now we're going to click on this little regression button. The default preset is linear. You can tell right away the equation of the line is negative 4x plus 36. And that b is 36. But even if you were having some trouble, or let's say the b was a fraction, what you could do is you could export it as a custom regression. And then you could, come down here and you could type in m and b, and it would tell you like the fractional values or the, of a repeating decimal. If it would pop up with the fraction button over here if you need it. So that just makes it abundantly clear. I think you can just look at the equation, negative 4x plus 36, write that down, compare it with your mind's eye, and see that it's choice D. Okay, question 15. I go over this in great detail in my Ottocento number 25, Advanced Exponentials. I'm going to assume you've already watched that, so please go watch that if you haven't already. I got the equation on the screen. So it says the population doubled. That means B, the multiplier, is 2. And then we've got this keyword every 75 years. So that means N is 75. Now, the only thing is you'll notice they didn't tell us the initial population. They didn't tell us the population in 1659. So I'm just going to leave that as A. We don't know what that is. So this is the equation for this situation. Great. So now they told us that the population of this town was 240,000 in 1959. So what we can do is we can define X as always the starting year in the problem. So X is the years since 1659. So if we make a little XY table, we're going to do some fast maths here. 1959 minus 1659, that's 300. So it's been 300 years. That's our X. And the Y is 240,000. Okay, so you can kind of see what we're going to do now. Pretty much our only option. They give you an equation and a point. It's just a standardized test thing, nothing to do with math. They give you an equation and a point, you plug in the point. So let's do that. So we got 240,000 equals A, we don't know. 2 to the 300 over 75. 300 divided by 75 is 4, so this is 240,000 equals A times 2 to the 4. 2 to the 4 is 16, so to get A by itself, we're going to divide both sides by 16. So 240,000 divided by 16, we get A equals 15,000. And because, and that's what they're asking us for, right? Because we defined X as the years since 1659, A, the initial value, is the population in 1659. So we're done. They basically, the whole point of this question was just they want you to understand and write the full equation for this exponential. I don't think this really saves any time, guys, but just because I figure someone's going to ask, if you want to, you could do a manual regression on that one point to figure out what A is. Again, I think dividing by 16 doesn't take that long. I would just do it that way. Okay, question 16. All right, guys, so when you have a scatter plot and line of best fit, the actual Y values come from the dots. The predicted Y values come from the line. When we want to find something about the line of best fit, you need to just look at the line. You need to completely ignore those dots, pretend they don't even exist. That's basically, you're going to see later, that's basically, aside from not knowing how to read a graph, that's basically the only way to get it wrong is if you look at the dots instead of the line. So just completely ignore the dots, pretend they don't even exist. Just with your mind's eye, stare at that line. Okay, so we're going to pick 2 points on that line. And I suggest you pick ones that go through corners, like grid markers, and ones that are kind of far away from each other. So I think they gave us 2 like pretty much perfect ones. And I think they did that on purpose. So I'm noticing this one, there's one on the left side of the graph that goes through a corner. And there's one on the right side of the graph that goes through a corner. So I think that first one is 3, 5. And that second one is 8, 8. And now we're just going to use the slope formula. So this is x1, y1, and this is x2, y2. So I'm doing slope is 8 minus 5 over 8 minus 3. That is 3 over 5, which is 0.6. And that pretty much exactly gives us choice A. All right, so now don't forget, guys, when you're given 2 points, just like we've done many times so far in this video, you can just get the equation of a line, including the slope, from Desmos. So let's go do that. All right, so we'll first make a table, and then we're going to put in 3, 5, 8, 8. And we just click on the regression button, and we can very clearly see that the equation is y equals 0.6x plus 3.2. Even if it was just a little bit off because you misread the graph, you can tell from the choices that it will probably be very close to 0.6. So we still get the same thing, 0.6. Okay, question 17. First, always make note of when they tell you what kind of function it is. This is a quadratic function. You should make a note of that. All of these equations are in this like weird modified factored form, and there's definitely some concept they want you to notice here, but I'm pretty sure the easiest way to do this is to just guess and check the points. So all I did was literally type in the very first one, 24. So I made x 24, and then for the first one, I got 4. Second one, I got -8. Third one, I got -96. And the fourth one, I got -160. So you would think we would have got -8 for 2 or 3 of them on the first one, but we didn't. So we could, this one has to be wrong. This one has to be wrong. And this one has to be wrong. So it has to be B. I don't even need to keep going. This is question 7. Who wrote this? Like, hire me, College Board. Like, I'll help you. It's like, this is, I don't understand what the point of this question was. Anyway, I guess we can jump to Desmos if you're having trouble with the substitution. Okay, guys, so something I like to do is to just call the different choices A, B, C, D, and that helps me. All right, so you see I typed in A of 24, B of 24, C of 24, D of 24. The only one that could possibly be right is B. And you see here, if we wanted to be more thorough, or if we had a question with better trap answers, you would go and check every single one just to be certain. And you see B, it's got every single point, so we're good. Okay, question 18. I have a great short on this. It's called Equation of a Circle. Definitely go watch that. It's only like a minute long, so I'm just going to assume you've already watched it. So the equation of a circle is x minus h squared plus y minus k squared equals r squared. The center is h comma k, and r is the radius, so we're just going to put those numbers in. So x minus h is 19, plus y minus k is 18 squared. And then this is really important. Whenever you substitute something, guys, you got to put it in parentheses. So 9k squared. We didn't have to put the 19 or the 18 in parentheses because it was just one thing. But 9k, it's like two things. So to make it more clear that it's both getting squared, we're going to put parentheses around it. Okay, so that gives us x minus 19 squared plus y minus 18 squared. And then distributive law of exponents tells us that this guy gets squared and this guy gets squared. So 9 squared is 81. And k squared is k squared. That should be the equation of the circle. And that gives us choice B. And there are ways to do equation of a circle on Desmos. I go over it in my other videos, but again, whenever the equations are in the nice form, it's a big waste of time. Actually typing it in takes a lot longer, so make sure you know how to do this. Okay, question 19. This is an old SAT favorite. So whenever you see like a downwards facing line and there's no clear independent variable, I guess what I mean is the variables, they do depend on each other, but they don't really feel like they depend on each other. So you see like number of m-type stars, number of k-type stars. Usually it's like x-axis is cost and y is money, or x-axis is time and y-axis is money. It makes sense that time affects money or earnings or something, right? It doesn't really make sense that number of m-type stars affects number of k-type stars. Another example would be like you got a farm and it's like number of cows, number of horses. It's not really clear how they're related to each other, right? They kind of seem arbitrarily grouped. Like I could swap x and y and the problem would still make the same amount of sense, right? Anyway, so when you get a problem like this, the crux of the problem is usually to pick out one of the intercepts. So I'm just going to pick out both of them. So there and there. So that first one is maybe 0, 1, 38. And that second one is like 158, 0. It's multiple choice, so as long as we're close enough, we'll be fine. Okay, so the question's asking me at the end about m-type stars. You'll see that down here. So I have a feeling it has to do with the m-type stars intercept. So we've got 158 m-type stars. And 0, that's what the y means. The y is the k-type, so 0 k-type. And now we're basically done. So the question says that the estimated total mass, so every single point essentially has a mass of 127,882. Every single point on that line has a mass of 127,882. And now it says it wants the mass of each. Each is like per. It's like a division word in units, like miles per hour, miles each hour. M-type star. Okay, well, when there's 158 M-type stars and no K-types, the mass is that. So we're going to do 127,882 divided by, and that's quetograms. I don't know how to abbreviate that. Divided by 158 M-type stars. And let's see what we get when we do that. I am getting about 809 is rounded, you know. And that is definitely closest to choice A, which is the answer. Okay, question 20. I go over this in great detail in my Otacento number 11 on SOHCAHTOA. I actually do examples just like this. So I'm just going to assume you've already watched that. If you haven't already watched it, go give it a watch. There's a free worksheet with problems you can practice. Okay, so the first thing I'm going to do, it says, what is the length of QS? Always, 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 whatever you're trying to solve for, just add that to the picture. So I'm going to put an X here next to QS. All right. Now, this is the really tricky part. Which angle do we use? They don't really tell us in the question, right? Which angle do we use? Do we use Q or do we use S? Well, if you look at the trig ratios and all the choices, just take a quick peek, you can see that they all have Q in them. So we kind of have to use Q. So that's kind of convenient. So we're going to circle angle Q. And now we'll label the HOA, Homeowners Association. That's a joke. So we're going to do the hypotenuse. That's across from the right angle. So hypotenuse. Opposite is across from the angle of interest. Opposite. And then the final side is the adjacent. So we don't have the adjacent labeled at all. So we're just going to use these two, opposite and hypotenuse, which we can see is sine. So we're going to do sine of angle Q is equal to opposite over hypotenuse, 18 over x. I go over this algebra when the x is on the bottom in that video. When the x is on the bottom, you essentially just swap these two, multiply both sides by x, divide both sides by the trig ratio, or you just do it in one step, swap them. We get x is equal to 18 over sine q, exactly like in the video. And that looks like choice D, which is the answer. Again, guys, I think the trickiest part for this one was which angle do we use? Don't be afraid to take a little peek at the answer choices to see if it gives you a hint as to how to get started. Okay, question 21. So, first thing we're going to do is we're going to make a table. You can see this is just the domain restrictions, not really that important for this question. What we care about is that part in that second sentence, which tells us the points. So really important, they said F is the predicted brake power in BHP, and then X is the engine speed in RPM. So just make sure you don't mix up X and Y. That's like probably the number one mistake here. Okay, so so that it says, let's look at this one first. So okay, so remember X is the RPM. They gave us that second. That's confusing, but we got to put it first in the table. So 3, 3, 3, 1. And we got a BHP of 433. And then we got, again, RPM is X, guys. That's got to go first in the table. 4,500. That's probably where most people messed up, honestly. Okay, so now we can just start plugging in points into that function. And what kind of happens is, if you plug in the first one, I think what's going to happen is we're going to subtract 433. We're going to get 0. And then it's going to be like a trivial case. And actually, no, this should work. I forgot to replace the X. Let me fix that. 3331, right? Yeah, maybe both of them work. I don't know. Anyway, subtract 433 from both sides. We get 0 equals 1/7. 3331 minus A. Okay, we divide both sides by 1/7. Still just 0. And now I can add A to both sides. And I get A equals 3331. And that is the answer. I bet if you use the second point, you get the same answer. So, okay, that was pretty good. That's a pretty nice question 21. It's worded a little poorly, but the other thing is too, guys, you could do this. If you didn't know this, you could regress on a you could do a manual regression and get the answer. Let's go do that. Okay, so just instead of clicking on this button, I'm going to regress it the way they did in the question. So instead of f of x, we'll put y, which in regression speak is y1. So y1. Instead of equals, we put tilde. Then we put 1/7 instead of x, we put x1 minus a plus 433. And looks good. Goes through perfectly. Tells us a is 3331. Again, I think the hardest part was just figuring out what was x and what was y. Okay, question 22. The Desmos way is like a bajillion times easier, so we're going to open with that on this one. We're going to, do things a little bit differently. Whenever you see it mention, as I said before, how many solutions, we're going to go to Desmos and we're going to do y equals left-hand side, y equals right-hand side. So let's go do that. Okay, so I just typed in y equals left-hand side, y equals the right-hand side. What I would do is I would always just make sure you zoom out just to make sure we're not missing anything. And I don't think we are, so I'll click on the house to bring me back to default. And we want to see where the blue touches the red. It seems that happens at 1, 2, 3 locations. So there are exactly 3 solutions. So the answer is B. Let's go back to the whiteboard and go over how to do it by hand. Okay, this is essentially just the zero product property, which I go over in my Ottocento number 4 on factoring. So there are 3 core factors. There's the 52, the x cubed plus 64, and the x to the 4th minus 81. 52 can never be equal to 0, so we don't care about him. But maybe these other ones can be equal to 0. So we're going to go and try to solve each of these. We have x cubed plus 64 equals 0. I'm going to subtract 64 from both sides. I get x cubed equals minus 64. Odd powers retain their sign. So really all we need to do is solve it. We don't really need to think about it. So I'll show you guys, if you don't know how to do a cube root on Desmos, you just press CBRT. The cube root of negative 64 is negative 4. So the solution that goes with that factor is negative 4. Okay, let's come back over here. Now we're going to do x to the 4th minus 81 equals 0. We add 81 to both sides. And we get x to the 4th equals 81. And now we're going to go and take the 4th root of both sides. But because it's an even power, when you take an even power, when you take an even root of a positive number, you have to put a plus or minus sign. So this is what they're banking on you messing up. Again, if you do it on Desmos, it's way easier. But this is what they're banking on you messing up, is forgetting to put that plus or minus sign. So we get x equals plus or minus whatever this tells us. And again, if you didn't know, you could type in a 4th root by doing nth root. Maybe I should do that a little bit slower. So nth root, and then when you get to t, it'll change. You do 4 tab 81, and I am getting 3, so this would be plus or minus 3. So the 3 unique solutions, they're all different, are negative 3, 3, and negative 4. 3 solutions, so the answer is still B. Can't stress enough, I think this was just like a freebie if you did it on Desmos. Okay, this is the beginning of Module 2A. If you'd like to skip to Module 2B, you can do so using the chapters in the bottom of the description. Let's get started with question 1. All right, this question wants us to find the y-intercept. So we're looking where the graph touches the y-axis, which is very conveniently labeled here with a little dot. I read the x-coordinate, it's at 0, and the y-coordinate is at 4. So the answer to this problem, it just wants the y-coordinate, so the answer is 4. Okay, question 2. So this says we already have 3,026 words, and we want to find the number of additional words. So we could call the number of additional words x, and additional means like we're adding, so we could write x plus 3,026. And it says no more than 5,000. No more than is a key inequality word for less than or equal to. So we're going to put less than or equal to 5,000. Now to solve this inequality, we'll just subtract 3,026 from both sides. So we do 5,000 minus 3026. And we get x is less than or equal to 1974. So the greatest additional number of words we can add is 1974. Okay, question 3. So it says how many had a diameter of 16 inches? So we're going to look at this top lot. We're going to look at 16 and simply just count how many there are. I think there's 1, 2, 3, 4, 5, 6 in that first column. So the answer is choice B. Okay, question 4. So they tell us that f of x is equal to 63. And f of x is also equal to this. So we can take this 63 and substitute it in here. It's like our y value. So this is 63 equals 9 parenthesis 2x plus 3. We'll first divide both sides by 9, and we get 7 equals 2x plus 3. Now we'll subtract 3 from both sides, and we get 4 is equal to 2x. And now we'll divide both sides by 2, and we get x is equal to 2, which gives us choice A as our answer. We can also do this problem entirely on Desmos, so let's go do that. Okay, all I did here was type in these two equations from the beginning exactly as they were written. I'm going to zoom out until I see both colors, zoom back in to see where they meet. Click on the point of intersection. And that happens at an x value of 2. So sometimes when you label two functions as f, Desmos can get a little confused. It's really important to understand that when you have f of x equals 63, any function notation like this, what's inside the parentheses is x, and what's on the other side is y. So perhaps a better way to write this would just be simply y equals 63, and you get the same answer. Okay, question 5. So we have 10x equals 86. The 10 is being multiplied to the x. The opposite of multiplication is division, so we'll divide both sides by 10. And we get x equals 8.6. You can also put its fraction equivalent, which is, I believe, 43 over 5. You can also solve basically any equation on Desmos, so let's go do that super quick. Okay, so I typed the equation in. I'm going to click on this little x-intercept here. We get 8.6, and I think terminating decimals are fine. I think 8.6 is a great way to just put it as your answer, but just in case you were wondering where the 43 over 5 came from, that's also accepted. You don't have to put both, just put one. Okay, question 6. So it says she gave 10% of them, talking about the cherry tomatoes. Well, she has 750 cherry tomatoes, so the question is essentially asking us 10% of 750. I go over this in great detail in my Ottocento number 1 on percents, and I have a short called percent of. That might help you if you go watch that. Anyway, so we're going to change the percent to a decimal by doing 10 over 100, and then we change the of to multiplication. And 10 divided by 100 is 0.1 times 750. And 0.1 times 750, you could do that on a calculator if you want, is 75. We can also use the percent of command on Desmos, so let's go do that. Okay, so I don't recommend this for more algebraic, more challenging problems, but for quick numerical calculations, this is pretty convenient. You just type in the percent E, and then you put in the second part, 750, and we get the same thing, 75. Okay, question 7. So for slope-intercept form, that is y equals mx plus b. I have a bunch of shorts going over slope formula and equation of a line. You should definitely go watch those if you got this one wrong, give you trouble. So m is the slope, and b is the y-intercept. And y-intercepts always have an x of 0. So you'll see here there's an x of 0. So this number here is the b. So b equals 5. And then the slope they just tell us is 7. So the equation is y equals 7x plus 5. Notice I'm just doing it myself without looking at the choices. I feel like It's good so you don't fall for a trap or something. Anyway, for this one, as long as you knew what slope was, you knew slope was in front of x, right? And you knew the slope is 7. You just go through and check all of them. So this one's 5. Okay, that's wrong. This one's 35. Okay, that's wrong. This one's 12. Okay, that's wrong. And this one's 7. So really the only one it could be is C. So even if you didn't understand that 0, 5 was the y-intercept, which you really got to know, you still could have gotten it right. You also could graph it as well, but honestly, I think it's easier to just check the slope. Okay, question 8. We could do this one by factoring, or we could do it by isolating the square. I'm going to do it by isolating the square. First things first, I'm going to add 40 to both sides. And I get 8x squared equals 72. Now I'm going to divide both sides by 8. I get x squared equals 9. And now I'm going to take the square root, and just when you take an even index radical, like the square root, the second root, of a positive number, we get x equals the square root of minus 3. Just in this very specific case, when you take an even root of a positive number, we have to put a plus or minus sign. So I'm going to put that right here. So the solutions to the equation are 3 and negative 3. So the positive solution is 3. So our answer is A. I think this one's much easier to do on Desmos. Let's go do that. Okay, so as long as there's no curveballs in the equation, cubes, fractions with x in it, radicals, absolute values, you can generally just type it in from left to right. So I type it in from left to right, and I see that the solutions are negative 3 and 3. So the positive solution is 3. Okay, question 9. So this is testing us on our knowledge of parallel lines. However, what makes it a little confusing is that it's kind of embedded into this shape. So what I suggest you do when you have that to make it easier to see is kind of extend these sides, pretend they're going longer, and maybe that will make it easier to see the parallel lines relationship. So I'm going to like kind of shoot some of these sides out a little bit longer. Again, the parallel lines are BC, this one, and AD, this one. So maybe I don't need to extend these BA ones. As a matter of fact, maybe I don't want to be looking at those. All right. So there's kind of 3 main rules you got to know for parallel lines on the SAT. Corresponding angles are congruent. Alternate interior angles are congruent. And same side interior angles are supplementary. There's more than that, but those will, the vast majority of the time, get you the answer. So what this one is testing you on is alternate interior angles are congruent. So the x is 22 degrees, and the way you spot alternate interior angles is you look at the parallel lines in the transversal, and you draw like a Z, and the angles like inside the Z are alternate interior angles. So that one and that one, those are alternate interior angles. So they are equal, they are congruent. So the measure of y must also be 22 degrees. And that gives us A as our answer. Okay, question 10. I go over this in great detail, guys, in my Ottocento number 20 on probability. These problems get way harder, so definitely go check that video out and practice with the free worksheet. Okay, so you see it says probability, so that's why we're doing this. I have the formula on the screen. The probability is the desired outcomes over the total outcomes. So they want us to find the probability of a vegetarian sandwich. Okay, so that's 9 out of a total of 50. So the probability is 9 over 50. I don't think that simplifies, and even if it did, sometimes they don't simplify it in the answer choices anyway. As you can see, B is 9 over 50, so that's our answer. Okay, question 11. So I'm definitely going to focus on the equation with one variable in it first, which is the first one. So what we'll do is we'll divide both sides by 10, and we get x is equal to 11. Oh, and that's great. Now that we have one of the values, we can substitute that into the other equation. So we have 6 times 11 minus 63 equals y. 6 times 11 is 66 minus 63 equals y. So we get 3 equals y. And that is choice D. We could also do this question entirely on Desmos, so let's go do that. Okay, so I just typed those 2 equations in. Now I don't see 2 colors, so I'm gonna zoom out until I see 2 colors. Zoom back in where they meet. I'm gonna export that point and label it just so we can look at it. You can see the question wants the value of y. So y is the second number, which is 3. Lots of people would have just read it too fast and put 11. You did everything right, but you just chose the wrong answer. The y coordinate is the second number, which is 3. Okay, question 12. So we've got 1 point for each draw. So that would be like 1 times D. And then we're going to add that to the points from the wins. 3 points for each win. So we're going to do 3W. And that will add to the total, which this person earned 41 points. So we'll put 41. The 1 is implied, so we don't write that. So it would just be D plus 3W equals 41, which is choice A. So if you're having trouble seeing if it were multiplication or division, one thing you could do is you could arithmetize. You could try to read the paragraph and come up with some numbers that get for D and W that give you a total of 41 points. So what I did was I did a draws of 5 and then a W of 12. And I think, 12 times 3, 36, plus 5 is 41. And you could go and plug those into each and every choice to see which one made it true. And you'll see, as long as you picked good numbers, it does work for A and nothing else. So look, if I do 5 plus 3 times 12 equals 41, you should get 41 equals 41, which means we probably did a good job. I bet if you plug those numbers into the other choices, it does not hold true for choice B, C, or D. So A is the answer. Okay, question 13. I go over this in great detail in my Ottocento number 20 on probability. If you haven't watched that already, please go watch it. Okay, so the formula I already have pulled up here. Expected is equal to the sample proportion times capital N, which is the population size. So the sample proportion is 8 people in the survey out of a total of 300 people in the survey. So that proportion is going to be 8 over 300. And we're going to do it times capital N, which is the population size, usually a really big number, which is right here. So 30,000. And if you get this wrong, honestly, you probably just typed it into your calculator wrong. That's probably what most people did wrong. Why don't, just to be thorough, we go over that. So we can do 8/300 asterisk 3 and then 4 zeros. 1, 2, 3, 4. And I am getting 800 people. And that is choice C, which is the answer. Okay, question 14. I go over this in great detail in my Ottocento number 24 on basic exponentials, so definitely go watch that and practice with the free worksheet. A is the initial value, and B is the multiplier. Again, I'm talking about the A's and B's I wrote in blue, not the A in the question. That's really annoying that they used an A to represent B, whatever. So the question says how much initially? Oh, so we want the initial value, which is the number in front, which is 3,600. Now, sometimes they throw some curveballs in here. That's the answer. Now, sometimes they throw some curveballs in here and maybe like add some numbers to the side of the equation. So if you really want to be sure before you move on, you can remember that A is the initial value is also the y-intercept, which is always when x equals 0. So if we write out y equals 3,600, A, and then replace x with 0, A to the 0 is just 1, and then 1 times 3,600 is 3,600. That's a rule of exponents. Anything to the 0 is 1. So kind of a little in-between step here is we get 36 times 1, or 3,600 times 1, which is still just 3600. Okay, question 15. I go over similar and congruent triangle rules in my triangle proofs video. It's Ottocento number 22 on triangle proofs. Definitely go check that out. Okay, so I just put all the sides on the picture. I think I did that right. And the side we want to find, YZ, I labeled him with an X. You should always do that. Okay, so these angles marked with an A, those are congruent. And also these angles here are congruent by what's called vertical angles. I've got a short going over that. If you want to watch my short on vertical angles, go check that out. So, as covered in the triangle proofs video, these are similar by angle. So that means the third sets of angles are also equal, and we can use these angle markings to set up ratios to solve for x. So now we can do corresponding big over corresponding small equals corresponding big over corresponding small. So I'm first going to focus on a set of sides where we know both the sides. What's standing out to me is the 70 and the 21. And that is, notice how I'm paying attention to the colors, right? They're both yellow, green. So they go together, right? That's why I labeled them like that. So 70 over 21. If you're on your exam, you can label them with like smiley faces and hearts instead of colors, if that's easier. And now we're going to do one. So we did one where we knew both the numbers. So one where we know both of them. And now we're going to do one with the X in it. Well, the X is marked as yellow, blue. So we're going to look at yellow, blue. And it's kind of hard to tell, but we were able to tell from the 70 and the 21 that 70 is a lot bigger than 21, right? So the triangle on the left is the big one. So we're going to start on the left side once again, same thing. And we're going to do yellow, blue, which is 60, over the small triangle, which is the one on the right, yellow, blue, which is x. All right, tremendous. Now all we're going to do is cross, multiply, and divide. So we multiply 70 times x, we get 70x. And then 21 times 60, that's 1,260. And now I'm going to divide both sides by 70. And I get x is equal to 18, which is choice A. The mistake most people would probably make here, first of all, they maybe wouldn't recognize it's similar at all. But the big mistake people would make if they recognized it was similar is that they would mix up the sides because they're not looking at the angle measures based on like their markings, right? So mark them up with, I did colors, but you guys can do smiley faces or hearts or whatever, you know, like that to show which ones go together. And it will make your life so much easier. Just always look at those and put them next to your proportions so that you don't mix up the sides. Okay, question 16. I go over this in great detail, guys, in my Ottocento number 4 on factoring. It's a very, very quality video. Please go watch it and practice with the free worksheet. Okay, so more specifically, this is testing us on factoring out a GCF. So if you're having trouble finding the numerical component of the GCF, what you can do is you can actually go to Desmos and there's like a command. I don't know how much it helps, but it might help for a future problem. It's called GCD. And you see it's good. We got 64 and 56. So the greatest common divisor, or GCF, the numerical component of the GCF, is 8. That's the biggest number that goes into both of those. You should know that from your times tables as well, but just in case you were having trouble seeing it. Now, to see the variables, you kind of want to see the least amount of times. Make sure they both show up, that it's common. And then if they both show up, you want to see the least amount of times it shows up. So t shows up twice and 3 times. So we're going to pull out the least amount of that. So 2, 8t squared. And now we're going to look at the s's. So there's 3 and there's 1. The least out of that is just s to the 1. So we're going to pull out s to the 1 or just s. Okay, so now to do the rest, we are going to pull out 8t squared s. And then see what's left. So I'm going to pull out, this is division, so you could just write this like this to make it easier for you to see. Factoring out a GCF is kind of like dividing. So I get 8, the t squareds go away, s cubed divided by s is s squared. And then minus 56 divided by 8 is 7. So I'm going to put 7, and then t cubed divided by t squared is just t. And then s divided by s goes away. So we get 8t squared s, parentheses 8s squared minus 7t. Okay, so now this is like super silly. They didn't even pull out the greatest common factor, right? Like, there's no 8, even though you can totally pull out an 8. They just pulled out a 4 for some reason. So we could redo it, or like, you know, taking out a 4, e squared s. Let's see if that gives us one of the options. So the variable parts will stay the same, but instead you're dividing by 4. So 64 divided by 4 is 16, and then 56 divided by 4, that's 14. So is there a choice that's like that? 4t squared s, 16s squared minus 14t. Yeah, wow, that is really weird. I don't know why they would ask you to factor out the GCF and then not actually make you take out the GCF. Who wrote this question? So anyway, I think this honestly, because of this curveball, even though that wasn't so bad, I think this might be easier to do on Desmos. So let's go do that. Okay, guys, so a really easy way to get, kind of guess and check equivalent expressions questions with letters that aren't X and Y, like constants, is to just plug in values for them. So don't use 1, and don't use the same number for both of them. So I like to do 2, 3, 4, 5, like that. So I made t equals 2 and s equals 3. I plugged in the original expression, and I got 5, 5, 6, 8. And now I type in all the other ones, and if the correct answer must give me 5, 5, 6, 8, and if none of the others give me 5, 5, 6, 8, that's the answer. So it seems like only choice D gives us 5, 5, 6, 8, providing I type that all in correctly. So D, by process of elimination, has to be the answer. Kind of lesson learned though, guys. I make mistakes too. When you're doing a test question, it's probably wise. It's not always wise to rely on the answers, but it's wise to just take a cursory glance. I probably should have took a look at all of them and noticed that they were pulling out a 4 before I got started. Okay, question 17. I have a short, guys, that goes over this. It's called base angles theorem. Please go watch it. We're not going to solve it that way. You'll see why in a minute, but you should really go watch my short on base angles theorem if this question gave you trouble. Okay, so first things first, we got a 15 and a 15. We need to recognize that these sides are congruent and that this is an isosceles triangle. More specifically, it's an isosceles right triangle. So we could use the base angles theorem, but I think for this one, it's way easier if you just look at the reference sheet. So I'm going to copy something from the reference sheet. Okay, so this is my own graphic of an isosceles right triangle, pretty much exactly how it appears on the reference sheet. Again, you just click on the little button in the top right when you're in the Blue Book app. And we can see that it has 2 congruent sides, these sides that are both S, and the acute angles, the angles that are not the right angle, are both 45 degrees. So that means this is 45 degrees, and this is also 45 degrees. So the value of X is 45. Again, guys, you're going to have to learn to do this for ones where the biggest angle is not 90, so where it's not a right triangle. So definitely go check out my short on base angles theorem. It goes over how to do this for ones with different numbers. Okay, question 18. So once again, we're going to look at that top right, and we're going to look at the reference sheet. I copied the picture and the circle formulas as they appear there. And we're interested in area, so we're going to use the area formula, area equals pi r squared. We already have the area of circle M, so we don't need to do anything with that because it's asking us about area, so that's good. We just need the area of circle N. It says it has a radius of 7 millimeters, so the area of circle N will be pi, and then we do 7 squared. 7 squared is 49, so this would be 49 pi. That's not the answer. I'm just going to put a box around that because that's important. So now it says, what is the total area? So we're going to add the two areas. So we'll do 49 pi, which is circle N, plus circle M, which is 64 pi, they said. So 49 pi plus 64 pi. Let's see. 49 plus 64 is 113, so this would be a total area of 113 pi, which gives us choice A as our answer. Okay, question 19. We'll do it by hand first. I'm first going to focus on the equation that just has one variable, which is the one I highlighted in yellow, the top one. To solve it, we'll just subtract 5 from both sides, and we get x equals 9. Right away, we can see C and D are wrong. Now I'm going to substitute this into the second equation. So we get y equals 4, 9 squared plus 4. 9 squared is 81. 4 times 81 is 324. And 324 plus 4 is 328. So if x is 9 and y is 328, the solution as an ordered pair would be 9, 328, which gives us choice B as our answer. This is much easier to do on Desmos, so let's go do that. Okay, so all I did was type the two equations in. I can see the two colors, but I can't really see where they meet, so I'm going to zoom out. And then I'm going to zoom back in kind of where it looks like they're meeting. You can click to help you with this. Oh, okay. So you see how that gray dot popped up? Yep, so I'm going to export that. I like to change it to green, and I'm going to hit label. And it's a little tough to tell, but if that gray dot popped up where those red and blue are, and there's no axis or anything near it, that's probably the solution. So we get 9, 328. Same thing, we get B. Okay, question 20. Actually just made a video on this, guys, at the time of this recording. It's called Quotient number 29, Factor Theorem plus Multiplicity. Definitely go check that out. There's a free worksheet. You can practice, get a lot better at this. All right, so first thing we need to recognize is that x-intercepts, or roots, happen when y is equal to 0. So it's really important that we recognized that for every single one of these points, y is equal to 0. So that means they're all x-intercepts. Another word for that is roots. So we can write these roots down. If there wasn't a 0 there, it wouldn't be a root. So -5, 1, and 4 are all x-intercepts. The factor theorem tells us that if k is a root, x minus k is a factor. So we're going to take the number we just got and do x minus that number. So we got -5, x minus -5. In other words, x plus 5. The second one, we have 1. So we do x minus 1. And then the next one is 4. So we do x minus 4. So the three things that we know for sure must be a factor are x plus 5, x minus 1, and x minus 4. Are any of those in the choices? I am seeing x minus 1 in the choices. So choice C is the answer. Okay, question 21. They give us two equations using x and y, and they're just asking us to graph it. So I don't know. I didn't even read the question. I just started typing this in. So let's get a clearer picture by zooming out. And I'm already kind of thinking it's C just from eyeballing, or sorry, choice B, this one down here. But how about just to be sure, what we do is, and this isn't foolproof either, you should try to compare all of them very carefully. But let's look at the point of intersection, the solution. So the solution should be at 3221. Okay. So let's come over here and see. Does that look like 3221? No, that looks like it's way before 30, so that's definitely wrong. Does that look like 3221? No, definitely wrong. Does that look like 3221? Again, not at 32. I don't even need to check the y-coordinate. This one kind of does look like it's at 3221. So while that alone might not be enough to get the answer always, it was definitely enough to get the answer for this one. And you can certainly rule out the others by just by looking at their shape as well, right? They don't have the right shape. They don't look like skinny to the left like that. I hope that helped. Okay, question 22. So we're going to do a minus b. So we're going to do 4k plus 5r minus b, which is 7k minus 12r plus 3. Really important, guys. When you distribute a minus sign to a set of parentheses, it's got to go to every single thing. So every single thing here needs to change sign. So if I start expanding this, I get 4k plus 5r minus 7k. The negative 12r becomes plus 12r, and the positive 3 becomes minus 3. Now we can combine the like terms. 4k minus 7k is negative 3k. And now we can do the r's. So 5r plus 12r, that's 17r plus 17r. And then the negative 3 doesn't really have a buddy to go with them, so we'll just put minus 3. And we should get negative 3k plus 17r minus 3. That is looking a lot like choice B. I will show a way to do it on Desmos, but I think doing it this way was way easier. Okay, guys, so what I did here was I just picked arbitrary numbers for the constants. I like to not use 1, and I like to not use the same number twice just in case it leads to a coincidence or something. So I made k equals 2, and then the next number I made r equals 3. I typed in a, it told me what that was. I typed in b, it told me what that was. And then I did a minus b, and it tells me the value of that is 42. So now if I type in all the answer choices, I should get 42. And if there's more than one, then you got to try another set of numbers. But we got very fortunate here. There is just choice B that gives us 42. So all the other ones are wrong by process of elimination. We get the same thing. Okay, this is the beginning of module 2B, question 1. First thing I notice is this word total here. That kind of tells me the things on the left side of the equation earlier in the paragraph we're going to be adding, and it's going to be equal to that number. Next, I see that it says we have a pass that costs $19.50, and it's just one pass. So that is a fixed cost, a flat fee. So we've got 19.50, and we're adding, so plus, and then it says 10 identical stickers. So there's 10 of them, but we don't know how much they cost. As a matter of fact, that's what they're asking us, right? So why don't we call that x? And we'll write 10x. And again, that's equal to the total, which is 62. Now we subtract 19.5 from both sides, and we get 10x. 10x equals 42.5. And then we divide both sides by 10, and we get x is equal to 4.25, which gives us choice B as our answer. And this doesn't really save this much time, but if you wanted to save, I don't know, maybe 10 seconds on your exam, you could type this equation in and then click on the intercept, and we get the same thing, 4.25. Okay, question 2. So what I notice is we have x plus y is equal to 125. Why don't I just replace that with this x plus y here? So we'll put 125 into there, to that thing I circled in red. So it would be 125 plus y equals 155. We'll subtract 125 from both sides, and we get y equals 30. We can also do this one entirely on Desmos, so let's go do that. All right, so all I did was I typed these two equations in. I don't really see where they meet, so I'm going to zoom out. Okay. I made a little mistake here. It's 155. There we go. All right. The x coordinate is 95, but that isn't what they were asking for. The y coordinate is 30. Okay, question 3. So it says Leo has $15. This is what's called a budget. And whenever you have a budget, generally you're going to do less than or equal to that number. So less than or equal to 15, because you can be equal to that amount in spending, but you can't go over it because you don't have more money. So whenever you see a budget, that should scream less than or equal to you. So right away, I'm seeing greater than or equal to 15 and greater than or equal to 15. And I'm already thinking those are wrong. So now, as long as I just don't mix up the variables, we're going to get it right, essentially. So let's see here. So we've got each container costs 187. The containers is C. Okay, so that should be 1.87 C plus each roll of tape costs 2.40. The numbers of rolls of tape is T. So that is plus 2.40 T is less than or equal to 15. And that is looking a lot like choice A. Okay, question 4. So whenever you have a scatter plot and a line of best fit, the actual y values are the dots, and the predicted y values you get from the line. So this question is asking us about the line of best fit. So whenever you want to find the equation or slope or y-intercept of the line of best fit, you need to completely ignore the dots. Just look at the line. So we're going to pick 2 points that are on this line. And again, just pretend those dots aren't there. Just pretend they don't even exist. So ideally what you want to do is you want to pick, so that we get as close as possible to actually answer, you want to pick 2 points that are kind of like on, like maybe one on the left side, one on the right side. Don't pick points that are too close together. So I'm going to try to look and see along this line and see if there's anything that goes through a grid marker. And again, not because there's a dot there. It has nothing to do with the fact that there's a dot there. You see the line touches right there at that corner. So I'm going to write that down. So that's, let's say 7,4. And now I'm looking towards the left end of the graph and like, none of them are really quite going through a grid marker. I honestly kind of like this one. That looks like about the y-intercept. It looks like about 0, 2.5. Why don't we write that down? Okay, so this is x1, this is y1. This is x2, this is y2. And we do y2 minus y1, so 4 minus 2.5 over 7 minus 0. So what does that give us? 1.5 over 7, which my calculator is telling me is about 0.21. And looking at the choices, it's not perfect because, we don't have the exact values. We just eyeballed it, but it just says closest to, so we just need to get close enough. And we can see it's C. It's definitely closest to 0.22 on there, right? That's all the other choices are farther away. Keep in mind, once you write the 2 points down, you can do the rest of this on Desmos very easily. Let's go do that. Okay, guys, so I just made a table by clicking on the plus button, clicking on table, and then I put the numbers in. And then as long as you got a line with 2 points, all you got to do is click on this little button here. And you can see very clearly the slope is that number in front of x, which is about 0.214, which is what I got doing it by hand. So honestly, I would just do it that way. It's probably way faster. Okay, question 5. So this wants us to interpret a point. You should not even read the choices. You should write down what the interpretation of the point is by literally copy pasting the words from the question and then go to the choices. If you just go straight to the choices, you're going to read it too fast and get it wrong. So there's no reason to leave it up to chance. It just makes it take an extra like 20 seconds. So x is 149.02, and they say x is the molecular weight in grams per mole. Okay, so when we have 149.02 grams per mole, and now it says 186.05 is y, and it says y is the estimated boiling point in degrees Celsius of a normal paraffin. Okay, so the estimated boiling point is 186.05 degrees Celsius. of a normal paraffin. Now that I have my own kind of crummy interpretation, I can go to the choices and I'm going to be way less likely to be tricked, I hope. So, okay, choice A says a molecular weight of 186.05 grams per mole. That's not right. We said 149.02, right? So that's got to be wrong. Okay, next one says a normal paraffin with a molecular weight of 149.02 grams per mole. That sounds good. And then it says an estimated boiling point of 186.05 degrees Celsius. That sounds right. I think B is the answer. Let's check C and D just to be sure. And also for the sake of the video. Okay, so now it says the minimum. Ooh, the question didn't mention anything about minimum. And if you look at the point on the graph, it's not even a minimum, right? Like there's points lower. So that just makes sense for like a multitude. It makes no sense for a multitude of reasons. If it were like a quadratic and the point were like down here, maybe it would be a minimum, but it's not. So right away, I think that's wrong. I don't even need to read the rest. Okay, and then this says maximum. Oh, that's not a maximum. Maybe if, you know, we're like a quadratic and it looks something like that, it would be a maximum, but you could clearly see there's points higher than that point in the picture. So it's not a maximum. So that one's wrong. So C and D are out. The only one it could possibly be is B, and that is the answer. Okay, guys, I just wanted to quickly point out what the minimum and maximum actually were. So the minimum is the lowest point, which happens right here, as you can see, right? I just highlighted it in blue. So that would be at 1, negative 175, and that's not even the point listed in the question, so it kind of helps you see that C is like wrong for a bunch of reasons, right? And then the maximum occurs, it says it goes to 280. So if I go to where 280 is, I guess that's like right here. That's the highest point, right? See how it's high up? So the maximum, I'm just eyeballing. This isn't exact, guys. So it's like 280, what is that? It's like past 325, maybe 330. You can see not only is, you know, 149.02, 186.05 not the minimum or maximum. Even if it were asking you about this, it would be having to ask you about those numbers in the question. If it said, you know, 1, negative 275 or whatever, then negative 175, then maybe you could say that as a correct choice, saying it's the minimum, but it's just wrong for a multitude of reasons here. I hope that helps. So you might have to, in a future question, recognize that a point is the minimum and the maximum. Minimum is the lowest point. Maximum is the highest point. Okay, question 6. So first I'm going to find f of 2. Just replace the x's with 2 in f of x. So it says x plus 6. I'm going to write 2 plus 6, which is 8. And then it wants us to find g of 2 as well. So g of 2 is equal to 6x. So 6 times 2, which is 12. So now we can do 7 f of 2 minus g of 2. That's going to be 7 times 8 minus g of 2 we said was 12. That's 56 minus 12, which should be 44, which is choice D. This is way faster to do on Desmos. Let's go do that. Okay, so all I did was just type the two functions in. Now on the next line, I'm going to type in 7f of 2 minus g of 2, and we get 44. Okay, question 7. I go over this in great detail in my short called Equation of a Circle. It's like 45 seconds long or something, so I'm just going to assume you've already watched that. I pulled the equation from that chart. Equation of a circle, x minus a squared plus y minus k squared equals r squared. So let's look at circle A. And we circle these two numbers. And we change the sign. And it tells us the center, so 5, so it's negative 5. Second part says negative 5, change the sign to positive 5. And then we circle this number, and that's r squared, so we take the square root. The square root of 25 is 5. Okay, so we have the center and the radius. I don't even think we need the center, but this is just good practice. You gotta know how to do that. Okay, so now let's look at circle B. It says the radius of circle B is 2 times the radius of circle A. Okay, so really important. The center doesn't sound like it's changing at all. They didn't say that, so the center should also be negative 5, 5. But the radius is 2 times. So the radius is 2 times 5 is 10. And now we can write the equation of a circle. So we were going backwards, and now we're going forwards. So x minus h, again, this is h, this is k, and that's r, right? So we're going to do x minus negative 5, that's x plus 5 squared, plus y minus k, y minus 5 squared. Again, that part looks the same, and the problem, you can see that, is equal to r squared, so 10 squared, which is 100. Now you can compare this to k in the problem, because the left side looks exactly the same, right? And we can see that k is 100. So the answer to this problem is 100. Okay, guys, so for expanded circle equations, you can use Desmos, and I go over that in my Desmos playlist, I think. But and in some of my other circles videos. But so I definitely don't do it when it's in the nice form. I was just going slow for the video, right? You could do this probably in 30 seconds by hand. However, you might want to graph it really quick just to make sure if you're prone to careless errors, you might want to graph it really quick just to use visual inspection to see if it's right. Okay, so let's see. Does it kind of look like the center changed? No, it kind of looks like the center's in the same spot. Does it look like the radius, if I just go with my finger, does it look like the radius is like double? Yeah, so that would probably be a quick and dirty way to check to make sure you did it right. Get some confidence in your answer before you move on. Okay, question 8. So we see this is f of x and this is f of x. So we can replace that top f of x with 63. 63 equals 9 2x plus 3. We divide both sides by 9. We get 7 equals 2x plus 3. We subtract 3 from both sides. We get 4 equals 2x. And now we divide both sides by 2, and we get x equals 2. And that is choice A, which is the answer. We could also do this one entirely on Desmos, so let's go do that. Okay, so I just typed these two functions in. Now I'm going to zoom out until I see where they meet. Zoom back in. And we see that happens at a y value of 63. But the question wanted us to find x, so the x value is 2. We get the same thing, choice A. Only thing I want to mention is, and I wrote this on the board, guys, f of x equals 63. The thing inside the parentheses is x. The thing on the other side is y. So it's not really a good habit to write f of x in more than one place because Desmos will get confused when you go to do function evaluation. So you should probably just call that y. So maybe a better way to type it, that second line would be y equals 63. And you still get the same thing. That happens when x equals 2. Okay, question 9. So I go over this in great detail in my Ottocento number 19 on quadratic formula. There's a free worksheet you can practice with. Please go check that out. It's very helpful. All right, so if you don't know what to do here, you should just take a glance at the question first. And this plus square root and the fraction as a whole should be screaming quadratic formula. I mean, now that I have it up here, you kind of see, oh, that does look a lot like the quadratic formula, right? But you're not going to really recognize that if you don't know the quadratic formula by heart. So you got to know the quadratic formula by heart. I have a quadratic formula sheet in my formula sheet video. Definitely go check that out. You can download it for free. Quadratic formulas on there. All right, so first thing we're going to do is identify A, B, C. So A is what's in front of x squared, 1. B is what's in front of x, 7. And C is the constant term, so that is 5. So we're going to write negative parentheses 7 plus or minus the square root of 7 squared minus 4. A is 1. C is 5. All over 2a, so 2 times 1. And you can go evaluate this, but I would really, lots of people make careless mistakes here. I would highly suggest you evaluate this part, and this part, just all on a calculator. Just ignore the square root. So you could type it in on your physical calculator, or what I like to do sometimes is just type in what a, b, and c are, and then type in the parts of the formula. So I typed in minus b squared minus 4ac, and I typed in 2 times 1. So from this, we can very clearly tell that it's something like this. That first part is -7. The part under the square root is 29. And the 2a, 2 times 1, is just 2. Maybe it doesn't help that much for this one, but when you have messier numbers, it's a big help. Okay, so we've got -7 plus or minus root 29 over 2. The next step would be to simplify the radical, split the fraction potentially, etc., etc. I go over that in my quadratic formula videos, but kind of fortunately, this already matches the form in the question, so we can just compare everything. So the k is the thing under the square root, which is 29. And that is the answer. Okay, question 10. So whenever we subtract a binomial, anything to a parenthesis, we got to distribute it to every term. So we have to multiply those terms after the minus sign by a -1. So they're all going to get their signs changed. This first one doesn't have a minus sign in front of it, so we don't need to do that here. So we've got 9x to the 4th plus 8x cubed, and then negative times 7. Okay, that's minus 7x cubed. And then we got minus times positive 5. That's minus 5x squared. Minus times positive 3, minus 3x squared. And then minus times positive x. That's minus x. Just change the sign of those guys at the end there. And now we can combine the like terms. Well, kind of fortunately, the 9x to the 4th, he doesn't really, there's no other x to the 4th, so he's good. Now let's look at the x cubes. We got 8x cubed minus 7x cubed, so that is 1x cubed or just x cubed. So far, it's looking like it's matching the thing in the question, so that's a good sign. And now we've got -5x squared minus 3x squared. That's minus 8x squared. And then the minus x is by himself, so we just put minus x. And now we compare this a in the x squared to this, and we see that a is minus 8. Notice how there's a plus sign in front of that a, so that means we keep the sign the same. So the sign is, so it's a -8, so we don't change the sign because of that plus sign right here. We keep the sign the same, so the answer is -8. A is equal to -8. We can also do this one entirely on Desmos, so let's go do that. Okay, so all I did was type in the 2 expressions in the question, make a slider for A, and it says can be rewritten in the form, so that means they're equivalent. So they should have infinitely many solutions. So let's do the wrong answer first. Let's start with D. Let's make a +8. Do they look exactly the same? No, they don't. I see red and blue in separate places. They're not the same. That one's wrong. Let's try 2. Those guys are not the same. They're not equivalent. Let's move on. That one's wrong. Okay, B is -2. Not the same. I see blue and red, so it's wrong. Let's try -8. Okay, so the blue perfectly replaces the red. That means these 2 functions have infinitely many solutions, and that means they are equivalent. So we did a good job. -8 is the answer. Okay, question 11. So doing this one by hand, probably the easiest way is guess and check. So we'll do that in a minute. I just replaced all the R's with the choices. So the first one's A, second one's B, third one's C, etc. And but first we need to talk about what inequality this is. Well, it's really hard to tell, but that is a -4, and this is a horizontal line. So the equation of that boundary line is y equals -4. So now because it is dashed, we are not going to use an equal to in our inequality. And because it's shaded above, we're not going to use a less than, because that would be below. So we want greater than, and then because it's dashed, no equal. So we're going to do y is greater than -4. That is the inequality in the drawing. So we're going to now go and guess and check all these other ones and see which one gives us that. So let's see here. I divide both sides by 15. I get y is less than 4. That is not right. A is out. Okay, I divide both sides by 4. I get y is less than 15. That is definitely not right. That's not the bound. That's not even the right bound. So that's out. Okay, I'm going to divide both sides by -4. I get -15. And then when you divide both sides by a negative in your algebra, you have to flip the sign. When you multiply or divide both sides by a negative, so notice how in our algebra we're multiplying or dividing both sides by a negative. We have to flip the sign. So we get y is greater than -15, which is also wrong. So hopefully it's this one. So let's see. We're going to divide both sides by -15. And we do get -4. And we get y. And then because it is multiplying or dividing both sides by a negative, we switch the sign again. So we get y is greater than -4, which looks good. So D is the answer. We can also do this guess and check process entirely on Desmos. So let's go do that. Okay, guys, I just typed in the inequality in the question exactly as it is. I'm going to press enter, which will hopefully make a slider. And now we're going to do is we're going to just guess and check the choices for R. So I'm going to do 15. Okay, that's shaded down. I don't even need to look at the bound. It's shaded down. Remember, ours is shaded up, so that's not right. Okay, let's try 4. That's also shaded down. That can't be right. Let's try -4. That's shaded up, so that could be right, but let's see, where is that touching the y-axis? That's at -15. We want it to be at -4, so that's wrong. Let's try the final answer, -15, which we know to be right. Okay, so that is shading up. It's got a dashed line. Looks good. Now we just got to check the bound. Is it at -4? It is, so D is the answer. That was probably the easiest way to do it. I would have done this one on Desmos for sure. Okay, question 12. I go over this in great detail in my Ottocento number 20 on probability. As a matter of fact, I'm kind of feeling like a prophet right now. I went over this exact question, I think, maybe with just like different numbers or something. I dug it up from an exam like 6 or 7 years ago from when I first started working. So yeah, this is pretty crazy. I'm actually beaming right now. I'm very happy. I wonder how many people, if this were on an official exam, how many people got it right because they watched my video. That's pretty cool. So anyway, so probability is desired over total. It says positive integers. So positive integers starts at 1. So like 1, 2, 3, up to 160. It's not a trick, guys. There's 160 numbers from 1 to 160. So the total is 160. Now we just got to think about the desired. So it says we want the probability of selecting a number that is even and less than or equal to 50. Okay, so from 1 to 50, and less than or equal to, from 1 to 50, there's 50 numbers, and about half of those are even. So we're going to do half of 50. Well, 50 divided by 2 is 25, and that's going to be our desired. So the probability is 25 over 160. That's not an answer choice, but we should definitely simplify it. And I know you guys, I've been tutoring a long time. I know you guys hate simplifying fractions. Guess what? Even if you forgot to bring a calculator, you don't have, and there's no calculator section anymore. So you really don't need to stress about it. All you do is type in the two numbers, 25/160, and then you click on this little fraction button here on the left. It's like a little circle. And we get 5 over 32. All right, coming back over here, that looks like choice A, which is the answer. Okay, question 13. I go over this in great detail, guys, in my Ottocento number 9 on basic statistics. It's one of the best videos I've ever made, and it's one of the most important. Most people don't even take a statistics class before they take the SAT, so please go watch that and practice with the free worksheet. So it says we're adding a new player, just one, literally just one, who has 18 points. So we're going to add like a little slither like right there. That's just meant to be 1 in that 10 to 20 box because 18 is between 10 and 20. Notice how, so this is what's called an outlier. It's far away from the rest of the data points. What we just did was we added what I like to call a small outlier. Notice how it's to the left of all the other numbers. It's smaller than all the other numbers. So let me pull up some notes. Okay, so I just pulled this from my formula sheet on statistics. That is also very helpful. You can download that for free by checking out my formula sheet video. And this is what happens when we add a small outlier, just like in this problem. The mean will definitely go down. Think about it. If you were, you had a B in your class and then you took got a 50 on an exam, your average is going to go down, right? And you don't need to do any calculation. You know for sure it's not going to help, right? With a median, it's either going to go down a little bit. It's either going to do what the mean does, just a tiny amount. So in this case, go down a tiny amount, or it's going to stay the same. We have to check. So we know for sure that the mean of the new data set is going to be less. So we know for sure it's going to go down, right? We don't need to do any calculation. But the median, we're not so sure. Not only can we not read the precise frequencies of this chart, it's kind of hard to tell, like for that top graph, is it 26 or 27? I don't know. But we can't compute the median to check because we don't know what the numbers are, right? It just says 50 to 60. We don't know if those are 51s, 52s, 53s. And the number of repeat values kind of determines, whether it's going to stay the same or go down slightly. So unless we can compute the median, we're not sure if it's going to go down or stay the same. We cannot check it. So I'm going to put a question mark. And again, notice how, guys, it says must be true. It could go down. It could be less, but we just don't know for sure, right? It might be the same as well. There's two options, right? Okay, so the answer is B, 2 only. Like I said, if you're still confused by this, go watch the Ottocento number 9. Okay, guys, little addendum here. This is still question 13. So I looked at the key, and they do want you to check to see where the median is, because if, even though you don't know what it is, if the median were here, and then for the first one, and then the median were here for the second one, you still know it's smaller, right? So let's just be really thorough. Again, I think we're going to discover the same thing. So position of median is equal to n plus 1 over 2. I go over that in my Ottocento number 9, and the median of a chart video. It's a chart, like 60 seconds long. Go watch it right now. It'll make way more sense. Called median of a chart. Okay, so we're going to do position of median equals n plus 1 over 2. So before we add the red guy, let's just ignore him. We're going to do 50 plus 1 over 2. And that is giving me 25.5, which is in between on the number line 25 and 26. So for the before part of the problem, we're looking for the 25th and 26th value. Now we're going to cumulatively add the frequencies until we hit 25 or 26. And this was really hard to get these precise values. It's kind of hard to tell. I checked to make sure they add to 50, so I think that I did it right. If you didn't know, you could do Control plus and Control minus on the Blue Book app to zoom in to the graph. It's very annoying. I don't know what the point of this question is. Anyway, so they should have put these numbers on top of the bars for you guys to make it more clear. Okay, so I did it. All right, so 4, no, it's too small. 4 plus 7, that's 11. No, that's too small. 4 plus 7 plus 27, that is way bigger than 25 and 26. So the 25th and 26th are both in there. So the median is somewhere between 50 and 60 in that bar there where we exceeded 25 and 26. We don't know what it is, but we know it's in this bar here. Okay, so now let's repeat the same process with n equals 51. So we're going to do position of median equals, because we added the one guy on the red now, right? 51 plus 1 over 2. That is 26. We get a nice whole number, so all we need is the 26th value. And this time we are going to worry about him when we do our addition. So we do 1. Okay, 1 is that's too small. Okay, so let's do 1 plus 4. That's 5, still too small. Plus 7, that's 12. Okay, still too small. And then we're going to do plus 27. And once again, you can kind of see that one value didn't really throw it off that much. I get 39. So the 26 must have been in that box. We went over 26, right? 39 is way bigger than 26. So we again see that the median is between 50 and 60. So we don't know. If we did that, we don't know because we don't know the numbers. So we're not sure if the median is the same or went down. Now, if all the numbers weren't in the same box, maybe we could say, so let's say we did that and then we found the 26th number was actually in here. We don't know what it is, but we know it's smaller than 50 to 60 because numbers between 40 and 50 are smaller than 50 and 60. So I don't know. They wanted you to be really thorough on this one. Again, maybe don't worry about it for this one, but for other questions, you really got to know this. Position of median equals n+1/2. Watch my other videos, please. Okay, question 14. I go over this in great detail in my Ottocento number 30 on ratio plus proportion. Please, if you haven't already, go watch that. Practice with the free worksheet. It'll help a lot. Okay, so you can set up the ratio any way you want. You just have to be consistent. I'm going to do, I don't know, just whatever they tell me first. So the first thing I see is inch. So I'll do inches over feet. And it says here 1 inch is equivalent to 17/3 feet. Okay, so we're going to put 1 on the top next to inch, and then 17/3 on the bottom next to feet. And now for the second sentence, we've got x feet. Remember, feet we put on the bottom, so that's x. And then it says which expression models the inches in terms of x. So that's what we want to find. A little confusing, so I'll put that with a question mark. And then I'll also mark it in blue to show that we're trying to find that, and we're not trying to find the x, right? Okay, so we can just cross multiply. So 17/3 times question mark is just 17/3 question mark, and 1 times x is just x. And now to move the fraction to the other side, we just multiply both sides by their reciprocal, so I'll multiply both sides by 3/17. And 3/17 times 17/3 is just 1, so it goes away. And we get 3/17 times x. A nicer way to write that, which more closely resembles the question, it's like x over 1. So you could write it as 3x over 17. And that is looking a lot like choice C, which is the answer. Okay, question 15. I have a short called Exponents and Radicals, which goes over how to change between radical and fractional exponent form. Definitely go watch that. It's only like 2 or 3 minutes long. I did pull up the equation off to the side there, but it'll make more sense if you go watch the examples. All right, so I'm noticing that in this equation, we have t by itself. So how about we make our strategy? We get t by itself up here, and then, we can kind of glue them together using substitution. So they're almost giving you a hint. You're meant to notice that the t is by itself in the question, in the text of the question. All right, so what will make this easier is if we change everything to fractional exponents. So we've got t to the 9/7, and then cube root of p squared. The power goes on top, the radical goes on the bottom, so he's p to the 2/3. And if you didn't know this, to get rid of a fractional exponent, what you do is, because we want to get t by itself, right? You raise both sides to the reciprocal power. So we're going to raise both sides to the 7/9. Think about it. It's power to a power. 9/7 times 7/9 is going to give you 1. So you'll get t to the 1, which is what you want. So we got to raise this side to the 7/9 as well. You don't need to do this in your head. So we got 2/3 times 7/9 because it's power to a power law. And that is giving me 14/27. Okay, so I got p to the 14/27 is equal to t. And then we have t is equal to p to the 3n-1 in the question. So let's do p to the 14/27 equals p to the 3n-1 just by substituting. All we did was take this and plug it in for t in that yellow right there. Okay, and now we have the same base, so we can use the 1-to-1 property. In other words, these exponents must be equal. So we can do, how about 14/27 is equal to 3n-1. I'll add 1 to both sides. And I get 41 over 27 equals 3n. And now I'm going to divide both sides by 3. And I get n is equal to 41 over 81. Which I believe is the answer. Let me check. Okay, that is right. It is 41 over 81. I think, look in the My Practice on Blue Book app. There are also some decimals you can put in. I don't know why you would do that. I would just use the fraction. Right, the calculator tells you the fraction. Maybe if you did it by graphing or something, that would make it easier. One thing we could do, I'm sure there's ways to cut out a lot of the steps, but I don't think that first step, raising to the 7/9 and then substituting, that only took, again, I was explaining it, that probably only takes like 10 or 20 seconds. So what you could do to save some time is if you recognize that this equation is just going to have one solution, you could type it as a regression statement. It's a really good strategy to quickly get the answer for an equation that you know is going to have one solution. And then if you go and just type n on the next line and click on the fraction button, it'll tell you 41 over 81. I mean, I just did that on my calculator in like 20 seconds, off screen. But, if you want to cut out that work or you're not as good at pushing the buttons on your calculator, you could do it that way as well, save some time. Okay, question 16. So this is a rational function, and they tell us that we have points 0, 22. And they also tell us this point in function notation for some reason. That's kind of weird. So the x is there and the y is there. It's just alphabetical order. It's not a trick. Negative 22, 0. Now the question is, which of these should we use first? Well, I'm noticing that this one, it has y as 0, so that's an x-intercept. And this one has x as 0, so that's a y-intercept. So this is oversimplifying it a little bit, but I think this is all you need to understand, is that x-intercepts happen when the numerator is equal to 0, as long as x is in the domain. Again, I don't think we need to worry about that for this one. Let's just kind of hope it works. The short version is numerator equals 0 for an x-intercept. So we can take that numerator, which is right here, and if we plug in that x value, negative 22, it should be equal to 0. So let's see. So negative 22 squared is 484. So we get 484 minus negative 22, that's plus 22, minus a equals 0. 44 plus 22 is 506. And I'm also going to add the a to the other side. So we get 506 equals a. That's not the answer, but that is really important. So we've got now g of x equals x squared minus x minus 506 over x cubed minus x minus b. So there's no special property for the y-intercept. So now that we know the 506, we're just going to take the y-intercept and plug it in. I'll do that in a different color if you want. So y is, again, coming up here. Y is 22, so we're going to do 22 equals x is 0. 0 squared minus 0 minus 506. And then 0 cubed minus 0 minus b. And 0 squared minus 0 minus 506, that's just negative 506 over 0 cubed minus 0 minus b, that's just negative b, because all those things at the beginning are just 0, right? These two negative signs actually very nicely cancel out. And now I can multiply both sides by b, and I get 22b equals 506. And we divide both sides by 22. And we get b is equal to 23. And we actually, which is choice A, that's the answer. We can actually do this one entirely on Desmos as well, which is way easier. So let's go do that. Okay guys, so all I did was I made a table, just by clicking on the plus up here. We've done it a bunch in this video already. And I put the points in, and then I typed the equation in that they gave us. But really important, I didn't click on this little automatic regression button. I did not click on that. I added a manual regression. So instead of g of x, we write y, or in regression, we write y1. Instead of the equals, you put a tilde, and then you got to replace all the x's with x1s. And you see it tells me A is 506 and B is 23. And we can clearly see by looking at the graph, you can zoom in on your own screen if you want, and you'll see that it goes through those 2 points nicely. Another way to tell that is you get an r squared of 1. That means it's like a perfect regression. So it certainly seems like we did a good job. B is definitely 23. Okay, question 17. I have a problem very similar to this that's actually a little bit harder. You might want to do it after you watch this explanation. It's in problem section number 12. The one you want is question number 3. You can just go to the description and skip straight to question 3 on that video. All right, so we're going to go to a different slide so I have more room to write, but there's 2 things we need to note here. It says one of these angles is 9x minus 140, and it says we want to pay attention to the sum of the measures of any 2 of these angles. So we're going to find 2 angles and add them kind of over and over again. You'll see in a minute. Let's jump to the other slide. Okay, so this is parallel lines cut by a transversal. You got, generally what happens is you have 4 acute angles that are all the same, and 4 obtuse angles that are all the same. And that is a total of 8 angles, but it's really just 2 angles repeating over and over again 4 times, right? Anyway, so I called the angles P, the obtuse angles P, and the acute angles Q. And this part doesn't matter. I called 9x minus 140 the acute angle. It doesn't matter. You'll still get the same answer, but that was just what I wanted to do. I figured, let me make him the acute angle. It doesn't matter. Okay? Now, this is really important. When you have, this is called a linear pair. When you have 2 angles touching next to each other and they form a straight line, they add to 180 degrees. This is called supplementary. So a really quick way to find the supplementary angle is to do 180 minus that angle. So for example, if that acute angle were 30 degrees, 180 minus 30 is 150. So that obtuse angle and every other obtuse angle in the picture would be 150, and every acute angle would be 30. So here we're doing 180 minus an expression, and what most people probably forget to do is they forget to put the parentheses here, and I bet there's a trap answer that has to do with that. So make sure you put those parentheses there whenever you subtract or add or multiply anything with multiple terms. It's really important to use parentheses. When in doubt, just put parentheses. Okay, so 180, we got a negative sign times negative 140. That becomes a plus 140. 180 plus 140 is 320. And then 180, the negative sign times the 9x is negative 9x. So it just gives us 320 minus 9x. And you'll notice I just put that in the picture everywhere for angle P. So we're basically good to go. So remember, it said to add 2 angles. So we just need to find all the possibilities that can happen of adding 2 angles. So it could be 2 P's, it could be 1 of each, or it could be 2 Q's. So I already did that off screen. Let's scroll down here. And 2P, that gives us negative 18x plus 640. 1 of each gives us 180. And 2Q gives us 18x minus 280. Let's take these, put them back next to the question, and see if an answer stands out to us. Okay, I think I did that correctly. So negative 18x plus 640, that's one of the ones we got. So it wants which one is not. So we're looking for one that's no good. Okay, 180, he's good. We got 180 as one of our options, right? And 18x minus 280, he's good. We got him as one of our options. Negative 18x plus 280 was not one of the possibilities for adding 2 angles that we got. So this is the correct answer. It's asking which one is not right. So another way to do it, if you wanted to avoid some algebra, is to arithmetize. So we could come up with a number for x and then guess and check, and the math will become a lot easier. So why don't we go do that? Okay, guys, so all we did so far was I picked a value for a, I remember I called 9x minus 140 the acute angle. So it gives us a valid acute angle. So a number between 0 and 90. You'll notice that, and I called that Q. Notice how, if I pick like 11.5 or 11, it's like, it's negative. We don't want that. It's got to be between 0 and 90. And if you pick too big of a number, it would maybe be obtuse, which doesn't really throw off the answer, but you want to be consistent with what's on your drawing. Anyway, so I did all these 2Ps, 1P plus 1Q, 2Qs. Those are all the possibilities, right? And we got 280, 180, and 80. Now we can take our value for x, which I just called a, and go and compare it to the choices and see if we get the same answer. Okay, guys, I wrote down the 3 numbers we got before, and you see we get the correct answer doing it this way too. If I use, again, a is just x, guys. Just made that easier to type into Desmos. And if I type in all those choices, I get 180, 80, 280, but for choice A, I get negative 80, and that's not one of the values we got when we were looking at our arithmetized picture. I hope this helps. Okay, question 18. You're definitely going to want to watch my Ottocento on triangle proofs. That's really important to solving this question. All right, so all I did was label all the stuff on the picture. They tell us the figure is not drawn to scale. And we need to start paying attention to the angles. They labeled those 2 angles for a reason, right? So these 2 are congruent here. Let me see if I can highlight those in yellow. And now we also have these 2 angles near the Q. Those are also congruent. That's called vertical angles. I have a short on that if that confuses you. And in the triangle proofs video, we talk about how there's 3 rules for triangle similarity: angle, SSS similarity, and SAS similarity. Well, we've got 2 pairs of congruent angles. So these triangles are similar by angle. So that means, even though they didn't tell us, if 2 of the angles are equal, the third angles must also be equal. So I'll label those in blue. And now we can set up a proportion to solve the problem. We're going to pay very close attention to our angle markings. What I like to do first is I like to focus on a ratio we know, where we know both numbers, and then find another big over small ratio that has the x in it. That'll help us get the answer, right? So I'm looking for a pair of numbers I know, and I'm noticing that we know the 70 and that we know the 21. And the bigger number is 70, so the bigger triangle is the one on the left. So this is the big, and this is the small. So we'll do yellow, green, and that will be 70 over 21. And then to find the x, we'll do yellow, blue, because that's where the x is, right? And the big yellow blue is the 60. And the small yellow blue is in the small triangle. It's hard to tell from the picture, but as we talked about from the previous ratio, we figured out that 70 is bigger than 21, right? So all the sides, all the corresponding sides in the triangle on the right are smaller. So we'll put x in the small. And now we just cross multiply and divide. So we get 70x equals 60 times 21, which is 1,260. And now we divide both sides by 70. And we get x is equal to 18. Where most people probably messed up is 1, they probably didn't even recognize that they were similar. But if you did recognize they were similar, you made a mistake, my guess is that you probably weren't paying close enough attention to the angle markings. You can't pick out those corresponding sides in your head. They're going to rotate and reflect the triangles to try to trick you. Mark them in some way and pay attention to your angle markings. You can't, it's kind of hard to use colors on actual test day. What you could do is you could use little like hearts and smiley faces and maybe stars and stuff like that to help you figure out which sides go together. So pay attention to the corresponding angles when you're making your side ratio. Okay, question 19. I go over this in great detail, guys, in my Ottocento number 6 on linear systems. I'm not kidding. It is the most important and best video I've ever made. If you're going to watch one video on the entire channel, I don't know why you're watching this one. Go watch that one because it's way more helpful. All right. This is one of the most commonly misunderstood topics, and most people don't understand all the strategies. We will go over how to do this by hand first, just for the sake of the video. So they're in standard form, so instead of getting them in slope-intercept form, which might take a while, I'm just going to set up some proportions and use the notes that I put on the screen. Again, if you want to make sense of those, go watch the video I was talking about. So we have 2 over 3, 9 over 13.5, and then 7 over 10.5. And now we're going to simplify these before we figure out if they're equal or not equal using our calculator. So I did 9 over 13.5, and I got 2/3. And I did 7 over 10.5, and I got 2/3. So these are all equal. So the first equal sign tells us same slope. Second equal sign tells us same y-intercept. So that means it is just like this one down here, and it has infinitely many solutions. So when the original equation is paired with option 1, it has infinitely many. Okay, now we'll look at option 2. It's the exact same, except there's just a negative in front of that 13.5. So we're going to have 2/3, negative 2/3, and then 2/3. And 2/3 is not equal to negative 2/3. And once you get a not equal to, you just stop. So we don't really care about this. We can just scribble this out. And you can see that first not equal to tells us different slopes, which means there is one solution just like this. So this guy has one solution. And really weird, the question says at least one solution. So basically, if it has one solution or infinitely many, it's good. So I guess both of these are good. And the answer is 1 and 2, which is letter C. This is way easier to do on Desmos, so let's go do that. Okay, so I typed in the original equation paired with Roman numeral 1. I'm going to zoom out. And I don't see anything, so I bet it has infinitely many. Let's zoom in a bunch and then toggle the second color. Yep, it's got infinitely many solutions. They are right on top of each other. So that part, we came to the same conclusion. And now I changed the second equation just to have that minus in front of the 13.5. And we can very clearly see that it intersects once right here. So that has one solution. So we got infinitely many and one solution. Both of those are, air quotes, at least one solution. So the answer is C. Okay, question 20. So I did pull the right rectangular prism from the reference sheet, which is in the top right corner. Unfortunately, the surface area formula is not on there. You're doing essentially length times width over and over again. There's 6 faces, 2 of each type of face. You don't have to memorize it, but remember, you don't have a lot of time on the SAT, so you might want to memorize it just to save time. It's all the way off to the right. We'll get to that in a second. So they told us the length, and they told us the height. So we're done with the problem, essentially, if we can find the width. You'll notice we need the width for the formula, right? So the base is a rectangle, length times width, and we can use the area they gave us. So the area is 24t, and that's equal to length times width. They said the length was 8/3, and then the width we don't know. So now we can divide both sides by 8/3. I just did 24 divided by 8/3 on my calculator, and I got 9. So 9t is equal to the width. So now we can just put this in everywhere. If you wanted to, length times width, that's equal to the area of the base, so you could swap that out. But I'm not gonna, just for the sake of, everyone being on the same page. Let's just have it match the formula. So we've got 2 times length. We said that's 8/3. That's in the question, right? And then the width is 9t. We got plus 2 height times length. Well, they said the height was 15. And the length is, we said 8/3. And then we got plus 2 times height times width. So the height is 15. And the width is what we said again, 9t. All right, so that first one, we got 2 times 8/3 times 9. That is giving me 48, and then there's a t, so 48t. That second one is giving me 2 times 15 times 8/3. No t on that one, so it's just 80. And then we've got 2 times 15 times 9, which is 270t. So now we're going to combine the like terms, 48t plus 270t. That is 318t, so we got 318t plus 80. And that is option B, which is the answer. You might not want to memorize, think more. Sattel Tutoring has a great video on surface area. You guys should go watch that. That's one of the best math videos he's ever made, I think. And if you don't want to memorize formulas for surface area, you want to understand surface area deeply. However, rectangular prisms show up on the SAT a lot. So this might be one surface area formula you want to know by heart. And there's one more thing I'm going to show you. Okay, guys, I don't think you should memorize this, but I just thought I'd mention that the surface area of not just a right rectangular prism, the surface area of any prism is 2 times the area of the base plus the height times the perimeter of the base. And you can solve this problem using that. I would encourage you to try it if that interests you. A little cheeky way to get that lateral surface area going around the side is to do height times the perimeter of base. It's a little bit faster. Okay, question 21. You're going to want to watch my 2 Ottocentos. The first one is my Ottocento on function translations, and the second one is my Ottocento on factor theorem plus multiplicity. So what we're going to do is I'm going to go ahead and brainstorm this function by examining the x-intercepts. So we're going to look at the x-intercepts. So we got, I think that's a -2, 1, and 3. So let me write that down, -2, 1, and 3. So if k is a root, x minus k is a factor. I go over that in the factor theorem video. So we're going to do x minus k. So x minus -2, that's x plus 2. Other factor is x minus 1. And the next factor is x minus 3. And now we find the multiplicity. Well, a multiplicity of 1 is like a straight line through the x-axis. And then if it like turns around, that's a multiplicity of 2. So you can see the first one here, it goes straight through, kind of like a straight line. So that has a multiplicity of 1. I go over that in the factor theorem video. And then both of these guys turn around, so they each have a multiplicity of 2. So this would be g of x equals a, x plus 2 to the 1, which doesn't do anything, x minus 1 squared, times x minus 3 squared. And we actually don't need to figure out what the a is because they kind of told us. And if you didn't know, moving the function left, right, up, or down doesn't change like the a at all. So we can actually just steal the a from here if you'll allow me to like cheat a little. So the a is 1/10. Why don't we go graph it and see if our graph matches that, and then we can do the rest. Okay, guys, my recording setup, it's a little cluttered, but you can see all the x-intercepts are right. They have all the correct local behavior, like that multiplicity. It has the correct end behavior. It's pointing the right way. We should probably just check another point. So a really easy point to check is the y-intercept. And I see I'm getting 0, 1.8. I read it as 2, but it actually does kind of look like a 1.8 now that I look at it. So I think we did it right so far. It's not, the vertical stretch factor isn't really going to affect the answer anyway. Okay, let's jump back to the whiteboard. All right, I go over this in the function translations video. To find g of x plus 28, what we're going to do is we're going to replace all the x's in the function g with x plus 28. So we're going to do 1/10 x plus 28. You could put parentheses around that, but we're just adding and subtracting afterwards, so I don't really need parentheses, so plus 2. And then x plus 28 minus 1 squared. And then x plus 28 minus 3 squared. Again, if you wanted to add some extra parentheses, you can, just to be sure. They don't really do anything for this one. Might do things for a future one, though. All right, so we get g of x plus 28 equals 1/10 times, okay, 28 plus 2, that's 30. So we got x plus 30. And then we got x plus 28 minus 1. That's 27. So x plus 27 squared. And then 28 minus 3, that's 25. So we got x plus 25 squared. Okay, so the question asks us what is the value of b, and you'll notice that is x minus b squared. So it's got to be one of the ones attached to, like if I write this down here, it probably has something to do with this one or this one, because those have power, both have powers of 2. So now lots of people would say 27 or 25, but notice how there's a minus sign here. So that means the sign of the constant gets changed when you put it in or pull it out. So the b's that go with each of these are really negative 27, because it's like x minus negative 27, which is x plus 27, right? And then the one that goes with that one is b equals minus 25. And we look at the choices, and negative 27 is correct, but it's not an option. So I bet it's minus 25. Now, there's a much easier way to do this, okay? And that is, you could pay attention to what g of x plus 28 means. If you understand what f of x minus h plus k means, like I go over in my function translations video, please go watch that, guys. We know that this is telling us that we're shifting 28 left. So you could go and just take the points and shift them 28 left. Just subtract 28 from them. And you see if you do 1 minus 28, that's negative 27. And if you do 3 minus 28, that's negative 25. That's because they wrote it in the factored form. So those numbers, when you take away the 28, gives you the x-intercept. So you could have just did that from the very beginning. You could just went and did the 1 and 3 and went, okay, we're moving 28 left, but let me move them 28 that way. And it would have worked. Also, guys, also, remember, if you did go and find the equation like I did, you can plot function translation. So look, g of x plus 28. Let's see what happens. And when I zoom out, oh, Kyle's right, maybe. That looks like it went 28 left, right? And you'll see, you can look at the x-intercepts. We got negative 30, but that one doesn't have a multiplicity 2, so we don't care about him. We just care about these ones, negative 27 and negative 25. But I either would have done it in my head. I just did all that for the sake of the video. I either would have done it in my head, like moving them 28 left if I were low on time. If I wasn't low on time, I would have found the equation in the first one and then just typed in g of x plus 28 and used that to answer it. Okay, question 22. I go over this in great detail, guys, in my OTA tutorial number 26 called Percent Relations. Lots of free practice problems you can download and watch in that video, so please go check that out. All right, so I'm just going to assume you've already watched it. Okay, so first we're going to do some words to math, and you know what? Just so that I know, right? Everyone hates doing percent math in their head, especially on the last question of a really long test, right? So we won't do it in our head. So let's see, we got A is, okay, so A is means equals 468% of, okay, so we do 468 divided by 100. You can use my percents formula sheet in my formula sheet video as well. You can download that for free. All right, that's 4.68 times B. Okay, that is the first equation. And now we're going to look at the second equation. A is 0.78% of C. So A is means equals, come back over here, 0.78 by 100. That's how we make a percent a decimal. Okay, 0.0078, and then it says C, so we're going to do times C. Okay, I think that's good enough for now. All right, So if we look at the very end, we would like an equation relating C with B. So what letter wasn't mentioned? Well, A wasn't mentioned. So we're going to substitute for A. If we substitute for A, that the letter we don't want, it will get rid of it. And very convenient here. Wow, we got A by itself for both of them. So we could just kind of set these two equal to each other. And just planning ahead a little bit, it says C is, so that means C equals. So we want to get C by itself. So let me write that on the left side just to save myself some writing. So 0.078C equals 4.68B. And again, it says C is, that means C equals. We want to get C by itself. So we got to move that 0.0078. So we're going to divide both sides by 0.0078. Wow, that comes out really nice. I got C equals 600 B. And it says C is P% of B. And now you guys can see, oh, the 600 is the P% of. So now we just need to change the 600 back to a percent. So we were dividing by 100 before. Now we're going to do the opposite because we're doing it backwards. Now we're going to multiply by 100. So it is 60,000%. Again, multiply by 100. We're doing the opposite of what we were doing before. And that is the answer. I want to point out, guys, that if it asked for a P% increase, if it said C was P% more, what you would do would be different. So you got to read it super carefully every single time. You got to know that percents formula sheet like the back of your hand, and you should really go do the practice problems in the Ottocento number 26 percent relations. They love asking these. Okay, that completes the lesson. Please be sure to like and subscribe for more digital SAT math content. And if you're interested in my tutoring services, the link to my website will be in the description. I tutor SAT math and all math subjects from about 7th grade to AP/early college level. Thanks for stopping by, and good luck studying.